Hi everyone! In this video, we are going to study about rotational kinematics. As you see here in this slide, you will see a linear motion here presented with all the formula, and then also presented rotational motion formula. As you can see that there is some same pattern between linear motion and rotational motion. In linear motion, we know some quantity as final velocity, initial velocity, acceleration, time, and displacement. In linear motion, we have x, displacement. In angular, we have theta, or angular displacement. In linear motion, we have velocity, while in angular motion, we have angular velocity. And the last one, acceleration, A, in linear, analog with angular acceleration, alpha in angular motion. So instead of using this equation, we substitute all linear quantity with rotational quantity. Final angular velocity equal to initial angular velocity added by angular acceleration times time. Theta, angular displacement equal to initial angular velocity times time added by a half angular acceleration time squared. Final angular velocity squared equal to initial angular velocity squared added by 2 angular acceleration times angular displacement. So in this formula, there is acceleration. That means the object is speeding up or slowing down. Well, if there is no acceleration, so it is constant in velocity, angular displacement equal to angular velocity times time. Example here, a CD rotates from rest up to an angular speed of 24 radian per second in 4 seconds. Find the angular acceleration of the disk. Find the angular displacement. And then, if the radius of the disk is 5 cm, find the final tangential speed. So here, there are several variables given from the question. Here, we know that the object is at rest. That means omega 1 is actually 0, and then omega 2, 24 radian per second, and then time elapsed 4 seconds. Let's write down all the variables. Omega 1 equal to 0, omega 2 equal to 24 radian per second, and then the time given is 4 seconds. Find A, angular acceleration, B, angular displacement, C, final tangential speed or final linear speed. Let's answer the first question. To find the angular acceleration, we can use the first formula, omega 2 final angular velocity equal to omega 1 initial angular velocity added by angular acceleration alpha times time. Omega 2 given is 24, and then omega 1 0 added by unknown times 4. So 24 equal to 4 alpha. We can exchange these two sides. 4 alpha equal to 24. So divide two sides by 4. We got alpha 6 radian per second squared. The next one, B, the angular displacement. We can use the second or the third formula. I'm going to use the third formula, omega 2 squared equal to omega 1 squared added by 2 alpha theta. As we know that omega 2 is 24 squared equal to 0 squared added by 2 times 6 times theta. So we have 24 squared equal to 12 theta. I'll move this one here and this one for here. We got 12 theta equal to 24 squared. I would like to write down like this: 24 times 24 over 12. So we know this is 2. So angular displacement is 48 radian. And then the last one, what is the final tangential speed? So to find this, V2, just multiply omega 2 by r. Omega 2 here given is 24 times 0.05. It is 1.2 meter per second. Next, a wheel is spinning at 15 revolutions per second. It spins for 30 seconds before it coming to a stop. What is the angular acceleration? And then find the angular displacement. So from here, we know that initial angular velocity is 15 revolutions per second. Then time elapsed before it stops is 30 seconds. So because the object is stopping, that means final velocity equal to 0. So given from this variable omega 1, can write 15 revolution per second, time elapsed 30 seconds, and then final 0. Find angular acceleration alpha. B, find the angular displacement theta. Let's answer this together. So to find angular acceleration, it's easy. Use omega 2 equal to omega 1 added by alpha times time. Omega 2 given 0, omega 1 given 15 added by alpha unknown times 13. So we can move this part here to the left. Minus 30 alpha equal to 15. So alpha equal to 15 over minus 30. We got alpha half of radian per second squared. Now find the angular displacement. Theta can be found with this equation. I prefer using the third one, omega 2 squared equal to omega 1 squared added by 2 alpha theta. Omega 2, we know that it is 0 squared equal to 15 squared added by 2 times minus half theta. So from here we know that 0 equal to 225 minus theta. So theta equal to 225 revolution, or if you want to convert it into radian, as we know 1 revolution is 2 pi. Radian. We can multiply 225 with 2 pi radian. So here we get 450 pi radian. That's that. Next question is this one. The angular velocity of a disk increases from 30 radian per second to 15 radian per second in 4 seconds. What is the angular acceleration of the disk? Right, so here given omega 1, and this is omega 2, and this is time. Let's find what is the angular acceleration. Instead of using omega 1, instead of using this equation, we can definitely use this equation. We can definitely use this equation, omega equal to final angular velocity subtracted by initial angular velocity over time. So we get 50 minus 30 over 4. 20 over 4 is 5 radian per second squared. Next, the wheel of a bicycle rotates with an angular velocity of 6 radian per second, then the wheels accelerate with angular acceleration of 4 radian per second squared, and the angular velocity becomes 22 radian per second. What is the angular displacement? For this one, we can use, this is omega 1 alpha, and then this is omega 2 given. So we can use the third equation formula. Omega 2 squared equal to omega 1 squared added by 2 alpha theta. Omega 2 22 squared equal to 6 squared added by 2 times 4 theta. So here 22 squared, let's use calculator. 484 equal to 36 added by 8 theta. So move this here, minus becomes minus 36 equal to 8 theta minus 36 equal to 448 equal to 8 theta. So theta 448 divided by 8, we got 56 radian. Ta-da! A carousel is at rest and it starts to turn with an angular acceleration of 0.4 radian per second squared. What is the angular velocity after 8 seconds? B. Linear velocity of a child that is 2 meters from the center. Last question. A bicycle slows down from 8 meters per second velocity to rest over a distance of 120 meters. The wheels have a diameter of 80 centimeters. Find the angular velocity of the wheels. How many times do wheels turn until they stop? angular acceleration, and time to stop. That's all for today. I hope you listen to this carefully, paying attention to the problem solving here, so you don't miss anything out. So in this case, I'll make more video to put in this lectures episode. See you guys, bye bye.